Hello everyone, welcome to my presentation. I am Ali and this is the presentation for Introduction to Nanoscience and Nanotechnology course term project, and my topic is the stability issue of perovskite solar cell. Let's get start with the definition of perovskite. What is perovskite? In the simplest way, it can be described as the structure in the cubic form unit cell with titanium atoms at the corners and oxygen atoms at the midpoints of the edge and a calcium atom in the center. Okay, what about the perovskite solar cell? And it's the name given to a group of materials with general formula A, B, or 3 having the same structure as the mineral calcium titanium. And perovskite solar cells are a novel type of device that was first fabricated in 2009. Yes. Why perovskite solar cells are important and what is the advantages of them? And in basic, they have high efficiency and low cost compared to the silicon solar cell. And some other uh, advantages of perovskite solar cells are could be in high performance tandem device architectures, structures in which they are combined with another absorbed material to deliver more power. And perovskite solar cells convert ultraviolet and visible light into electricity very efficiently, meaning they might be excellent tandem partners with absorber materials such as crystalline silicon that efficiently convert lower energy light. And you can see the picture of what I said. And what is the problem about the perovskite cell? And in the field of solar cell panels, the problem is mostly focused on the commercial events. And when an industrial solar panel investment wants to do, they take into account some criteria. These are the criteria, and it's called the golden triangle. And what are they? Cost, efficiency, and lifetime. And when someone make investment about the solar panel, the solar panel should be there, should stay there long time. But this is the problem for the perovskite solar cells. And you can see the comparison of silicon and perovskite solar cells in terms of cost, efficiency, and lifetime. And when you look at the cost, perovskite cell has more advantages than the silicon. And in the efficiency part, there's just little tiny difference, just 3% of difference. And but when you look at the cost and efficiency, perovskite solar cells are have more advantages compared to the silicon. But in the lifetime, there is a big problem for the perovskite because the maximum stability of the perovskite solar cells are just 1 year. And another problem about the stability is they don't withstand moisture, long-term life, or high temperatures. And to increase stability, researchers are investigating the deterioration of both perovskite materials and contact layers. Improved cell durability is crucial for the development of commercial perovskite solar products. Here is the factors affect the stability. It can be divided into two categories: and external factors and internal factors. And I mentioned about the external factors just a little bit here, and they are the moisture, amount of oxygen, and some other environmental factors. And actually, important factors are these ones: ion mobility, thermal instability, hygroscopicity. These are related with the chemical uh, index of perovskite solar cells. Yes, what are the some solution approach? And some of these problems can be solved by environmental methods like hygroscopicity, and some other solution is for thermal instability. Is intended to increase the decomposition energy or barrier in order to figure out the thermal instability problem. And some solutions for the instability are theoretical. I mean, there can be problem when they want to uh, make in practice. And actual uh, challenge is here in the optimization of both high efficiency and stability of Perovskite solar cell. Because when researchers want to increase the stability, that approach may affect the efficiency. But this does not mean that this obstacle cannot be overcome physically. Another important point is that environmental factors affecting stability should not be the first issue to be resolved because real solar panels are already covered to protect against such environmental factors. This is a method used in already existing system. Therefore, the first issue to be dealt with should be the internal factors. Yes, that's all for me. Here is the references that I benefited, and thanks for listening to me.